Good evening. Yes, it's 7 minutes past 6 in the evening. I just got back from the pizza house tonight, talking to my buddy Mike for quite some time. He was not there last week. This video is primarily for Doug Morslack. When he was doing that video on that toroid coil. I've never worked with the things, to tell you the truth. I'm not too familiar with them, to be honest with you. But that's not really exactly what this video is about. I wanted to make a point, and what I tried to do is to type out quite a long reply, or post I should say, to his video. And after a long time typing, you know how that is, I hit cancel by mistake, and ooh, was I ticked. So I said the best thing to do is to just make a video of it. A video's worth 100,000 hunt and peck types. So I don't know about your signal generator, Doug, but mine does not put out an equal amplitude on all bands, and I don't know, other than a professional one, would put out an equal amount. My ICO 324, I don't know what you're using for a RF signal generator, but I'm going to show you on the scope here. You can change bands and you're going to see a level, usually a decrease the higher you go up, and maybe even an increase, and I will demonstrate that for you. So what I was trying to say in that long typing, which was all wasted because it got canceled by me, is when you're testing the resonance of a transformer, what you want to do is have your dual trace oscilloscope, channel A on the output of your signal generator and channel B on the output of your transformer. And you're going to have a different amplitude, but the point is, in order to verify that the output change on the transformer isn't going up and down due to the fact that your signal generator may not be putting out, and I'm almost willing to bet it isn't, the same RF at one band or one range of the band than it does in the other. So as far as measuring the resonant frequency of a transformer, you don't really need to do that so much, but it's nice to check the output of your signal generator. So if you want to make sure that the signal generator is putting out relatively the same amount of millivolts across the band at any one setting of the output control on the signal generator. Your signal generator apparently puts out a smooth sine wave. My ICO 324 does not. The one I used to have years ago does not. So I'm not sure what you're using. I think you used the E200 or something like that, B&K. And I have mentioned this before, that I would like to be able to get a signal generator where I'll put up pure sine wave all across the band. And the ICO 324 is loaded with harmonics and does not put out a sinusoidal wave. And I don't think that's good. But let me show you on the oscilloscope using my ICO 324 to show you that the ICO 324, in my case, does not put out the same amplitude throughout the bands. So, as you can see, that is 400 cycles, well, 430 cycles, 429.35 to be exact. So, what we want to do here, let's set the output control until we get 2 divisions. 1, 2, peak to peak. And we're set at 5 millivolts per division. So we've got 10 millivolts peak to peak right here. Okay. But I'm not too worried about even the wave shape. I just wanted to point that out. So, just remember, get my glasses on here. Alright, let me push that up just a hair more here. And I will not touch the attenuation control from here on out. 3 divisions. Boy, am I blind. Sorry. 3 divisions. 1, 2, 3. Let's... Alright. 1, 2, 3. So we're 5 millivolts per division. 5, 10, 15 millivolts peak to peak is what we're getting. Okay? Alright, but just don't even worry about that part. Just watch the height as I adjust the frequency. I'm going to be going up in frequency from 400 kc and no, I'm going down. I'm sorry, I'm going down to 150 kc, and at that end of the band on the scale of the ICO 324, it's right on 150 kc. So let's. You can plainly see the amplitude has dropped. Let's get it so you can see it a little better. I have not touched the amplitude. We are under 2 divisions. We were 3. Okay? Now, let me switch bands. We are now on 391.9 kc, so almost 400. That's 400 kc right there, and the dial is almost right on. So it was off on the one band on one end, but that's not the point. Okay. Again, we got a drop in amplitude. 1, 2.5 divisions. We are no longer at 3 divisions. Now I'm going to turn the dial from 400 kc to 1.2 megacycles. Watch the amplitude. We are 1.2, let's see, we got to look at my magnifying glass here. We are, all right, let's put it right on 1.2 megacycles, right there. 1.2, let's see the divisions here. 1, 2.5, 2 3/4. Okay? Now we're going to go to band C. We're on 1.2 megacycles now, but if we go to band see we took a big drop, but we are on 3.5 megacycles. That's just the way the dial is. You got to crank it all the way around the other way. So we're going down in frequency. But I just want to show you. Let's put this right in the middle of the band on all of them. All right, 220 kc. We're just going to flip this dial here. We are 2 divisions, 1, 2. All right, 583 kc. 2.5 divisions. 1.8 megacycles. 1.8 megacycles. Little over 2 divisions. Two divisions, exactly 2 divisions, and we are at 5 megacycles. It's 5. All right, and close as I can tell, it's 2 divisions. 1, 2. That's a 5 megacycles. So let's work from 5 megacycles. And work down from there. That's down to 3.5 megacycles. Actually, it's a hair under that. So you can see right there, unless you got a professional signal generator, that if you set it for 5 millivolts output, for instance, which this is not a professional signal generator, it should stay 5 millivolts on all bands, and that's my understanding. I noticed, as I said in the beginning of this video, that your signal generator looks like it puts out almost a perfect sine wave. Maybe I should be looking into a signal generator such as you got that puts out a perfect sine wave instead of all this distortion in this one. Although it works okay for radio work and everything, but when you have to depend on harmonics, if you're working with very high frequencies, it's not an accurate way to do things. And also, your frequency counter doesn't like working with harmonics. So you don't really know if you're reading accurately on the very high bands or not, because you got a whole bunch of harmonics in here. So actually, this signal generator only goes up to 37 megacycles on fundamental, and everything else on your band F and F1, which is really, that's it. You just put it on F and you're getting a choice between these two, but it's really harmonics. In closing, I did not touch this attenuator, the coarse or the fine, nor did I touch the scope, volts per division. So naturally this is not a laboratory piece of equipment, of course, and it does good for putting out. I didn't have the modulation turned on anyways, even though this control is turned up. It was set on external modulation. So in other words, I was getting an unmodulated waveform out of here. So what I am trying to say, and I've been looking on YouTube, but the prices are, well, first of all, it's a boat anchor if I got anything that was putting out a pure sine wave. Or it would be an HP or something like that that would cost hundreds and hundreds and hundreds of dollars. That would put out a pure sine wave and would go up beyond 37 megacycles. I just don't like the waveform that's coming out of that. And of course, you're not going to get a linear response. But just for the heck of it, Doug, if you think of it, stick your scope on there and go from the lowest range till, let's say, 10 megacycles. That should be good. You don't really need to go much higher than that. Go from the lowest range of your RF signal generator to about 10 megacycles or so, and see if your amplitude changes as you go up and down the band. It may or may not. And maybe you can make a video on your signal generator using your scope to see how good the waveform looks over 10 megacycles. I'm not sure how high you went. I think you went to 1.5 megacycles or something. Even at that frequency, your waveform looked good. Mine looked crappy no matter where I started. Even at 400 kc, it's crappy all the way up. Now, I had a Hickok signal generator that gave a crappy waveform too. I'm not sure if it was a 288X or something in my old shop. I really don't remember now, but I do remember the waveform looked like this, like I showed you. Not a sine wave, that's for sure. And I think for these kind of tests, you want a pure sine wave. But also you want an even amplitude all across the band. All right. That's it, folks. I'm sorry I bored you once again.